Welcome to the solutions to the Regents Physics Forces as Vectors worksheet numbers 6, 7, and 8. Number 6, as the angle between the two forces in question 1, and the two forces in question 1 were 8 newtons and 10 newtons, is steadily made smaller, what happens to the magnitude of the resultant? And then a second question, is there any angle for which these two forces keep the body on which they act in equilibrium? Let's tackle the first question first. And we're taking the angle between the two forces and making it smaller. Well, what's the largest angle that can be between the two forces? The answer to that is 180 degrees. So the angle between the two forces is 180 degrees. That's the largest angle that can be between them. That would mean we would have one force, say the 10 Newton in one direction, and the other force, say the 8 Newton vector force in the other direction. Well, this, of course, would produce a resultant of 2. The smallest angle that can exist between these two forces would be 0 degrees. Well, if that was the case, we'd have a 10 Newton force and an 8 Newton force, not to scale, both pointed in the same direction, and this would give us a resultant of 18. So as the angle is made smaller, so as theta decreases, the magnitude of the resultant increases. And that's because you are getting closer. At 180, a min is produced. At 0 degrees, a maximum is produced. So as you decrease the angle, you get closer to that maximum value, and the magnitude of the resultant increases. The second part of the question, is there any angle for which these two forces keep the body in which they act in equilibrium? And the answer to that is no. In order for them to be in equilibrium, there's only 2 of them. They would have to be at 180 degrees, and they would have to be equal in magnitude. This second part is, of course, the reason why they cannot be in equilibrium. We can get them at 180 degrees since there's only 2 of them, but they are not equal in magnitude, therefore cannot be in equilibrium. Okay? All right, on to number 7. We have 3 forces acting at the same point of a body are in equilibrium. When 2 additional forces are now applied to the body, it remains in equilibrium. What must be true about the 2 additional forces? Well, let me use, for example, let's have a 10 Newton force pointed up, a 10 Newton force pointed to the right, and then let's have a 14 Newton force pointing in that direction, which would be 45 degrees away. This would represent 3 forces in equilibrium. Okay? This says we add 2 additional forces and the body remains in equilibrium. What must be true about the 2 additional forces? Well, what this says about these 2 forces is, one, since the system is already in equilibrium and you're only adding 2 more, that these 2 forces have to be equal and opposite to each other. That didn't turn out very good in the drawing, but equal and opposite to each other. So we could have this one be 5 newtons, for example. That means this one has to be 5 newtons, and they have to be 180 degrees to each other in order for this situation to mentioned in number 7 to remain true. Okay? All right, and lastly, number 8. Explain why the resultant of these two forces of explain why the resultant of two forces of unequal magnitude can never be zero. Well, in order to get a resultant of 0 degrees, it means that the two forces would have to be at 180 degrees to each other. To get a magnitude of 0 means you have to produce a minimum value, and you can't get more minimum than 0. Okay? So the issue here is, of course, once again, that the forces are unequal in magnitude. Okay? Because they are unequal in magnitude, when you place them at 180 degrees, you're going to get some, we'll use our same example as before here, you're going to get some non-zero resultant. The only way for you to get a resultant of 0 is to have them be at 180 degrees to each other and have them be equal in magnitude. So once again, the key to the question was that those magnitudes were unequal. All right, more practice with forces as vectors tomorrow in class. If you had any questions on numbers 6, 7, and 8 here, make sure you note them so that you don't forget what they are before you come in class tomorrow.